I'd like to welcome you to our webinar platform. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the Questions widget. Just type them into the box at the top left-hand corner of your screen and click Submit. We will allocate some time at the end of the session to address any questions or comments you may have. Please use the yellow Help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. Now, please allow me to share a short presentation about our company, followed by today's webinar. At INNIO, we are moving energy forward with a focus on innovative gas engines technology. We develop, manufacture, monitor, and service fuel-flexible engines for power generation and compression solutions. Our Jenbacher business is specialized in power generation. INNIO's Jenbacher North American Sales and Service Hub is headquartered in Houston, Texas, and we have operations in Wisconsin, USA, as well as in Ontario, Canada, with INNIO's global headquarters and our core innovation center based in Austria. Out of our more than 3,500 global employees, more than 500 highly qualified INNIO engineers are focused on innovation. INNIO's Jenbacher business has more than 2,000 employees around the world. The first Jenbacher gas engine was manufactured in 1957. In total, Jenbacher's success builds on more than 90 years of engine experience. So far, from about 25,000 engines for power generation and CHP delivered worldwide, around 1,100 have been delivered to customers in North America. Today, INNIO runs manufacturing facilities with a total of 65,000 square meters, producing 5 product lines of high-tech engines with outputs from 200 kilowatts to as high as 10 megawatts. Our engines are known for overall efficiencies of 90% and more, their durability, fast start capabilities, and the ability to run on a broad range of fuels, including hydrogen. Jenbacher also offers a comprehensive set of lifecycle services. Jenbacher has always been a frontrunner in the gas engine industry. In addition to a series of world's firsts in technology, the business also has a history of growth in the United States and Canada. What started with a small sales and service office in Boston 30 years ago has grown into a large network of expert INNIO and distributor sales and service, warehousing, and logistics teams across North America. Jenbacher engines meet our North American customers' needs with top reliability and performance, delivering total efficiencies of up to 95% in cogeneration mode. We offer established, field-tested designs, optimized, robust engine components, along with a proven monitoring and control concept. Our engines can run on natural gas as well as a broad variety of renewable or waste gases. This makes them a great solution for reducing our customers' CO2 footprint. With the capacity to run on hydrogen, the potential to save even more emissions in the future is becoming reality. Our service organization provides everything you need to profitably run your Jenbacher power plant. You choose your tailored level of support, and INNIO will deliver everything from the digital myPlant asset performance management solution for optimized uptime and reduced lifecycle costs, all the way to remote operation, as well as fast on-site service support from our team of technicians. We also run a remanufacturing program for efficient overhauls and provide you with comprehensive conversion, modification, and upgrade packages to help you make the most of your Jenbacher engine. Let's look at a few of the most interesting Jenbacher solutions for North America. Most Jenbacher power plants run in combined heat and power mode and use up to 40% less primary energy compared to conventional generation of heat and power. We offer innovative microgrid solutions for a stable 24/7 power and heat supply, even if cities face a blackout. With our innovative greenhouse solutions, we power and heat greenhouses and grow houses while cleaning the exhaust gas for use as fertilizer, which promotes plant growth. Jenbacher-powered data center power plants deliver lower emissions along with fast start capability based on reliable pipeline fuel operation. Using renewable wastewater gas in Jenbacher engines can provide 100% of a sewage plant's energy needs and in the long run, achieve significant cost savings. We are ready for H2. Jenbacher's products are prepared for a CO2 neutral world and can support you with engines ready to run on hydrogen today. When you choose Jenbacher engines, you decide for a greener and more profitable future. INNIO, changing the world with better energy.
Hello, everyone, and thank you for joining us today. Today, we'd like to talk about INNIO gas-powered generation solutions, specifically designed for the data center space. Today, it'll be myself, Curtis Chesler, sales manager for the data center space in North America, and Santiago, you're up.
Hello, good morning, everyone. Thank you for joining this webinar. I'm Santiago Carmona. I'm the Global Commercial Manager and Application Engineer for the data center industry. My role in Jenbacher is basically finding you to make power solutions for the data center industry.
So today we're going to give you a quick overview of the company and our solutions and some flagship projects that we've worked on. Currently, the product that we offer is designed from the ground up as a dedicated gas engine platform. Continuous running engines with engineering solutions for the fast start capabilities. As we all know, that data centers like to be up and running in a timely manner. So, a quick overview of the products that we offer from, as mentioned in the video, from the smallest 2 megawatts up to 3 megawatt for containerized solutions, 4 megawatt, and up to 10 megawatt uncontainerized solution. Type 6, for instance, which is the most recognized product for the data center space. It's a special offer, easily transportable container that allows for highly flexible operation in a variety of locations. Our data center solutions are what we're going to discuss today. So our fast start product is what we're going to kind of focus on as we touched on in the video. We are a hydrogen ready fast start to support direct replacement for diesels. It's a product that can also be used as grid support to lower emissions based on NOx and PM. Fuel flexibility, it'll run on natural gas, biogas, RNG, H2, whatever is required or whatever is available, let me say it that way, for the facility. Natural gas pipeline, as we know, is up to 3 times more reliable than the current grid. So fuel storage is not necessarily an issue. That said, we're going to hop right into our information that we can share moving forward.
Thank you very much, Curtis. Curtis just made a general introduction about gas engine and the potential application in the data center industry. Now I'm going to go a little bit on detail on the potential applications you may have as a customer. So basically, we're going to divide this into 2 parts: the backup power. So it's the new thing, let's say, in the market on the gas engines application globally, that we see a trend that is moving forward. And the traditional continuous power application that, you know, for the gas engines for the last 70 years or so. This is a generic presentation, so the contents are generic, although we're going to mention some technical details. So please send out in case you want to complement some of the information. Just please submit your question on the Q&A section, and we're going to answer the questions at the end of our presentation. So basically, going a little bit on detail on the first of the two applications. Let's say the new thing on the data center industry, or let's say the new thing on the gas application, is the possibility of using these units as backup application, right? So we are doing what the goal here in a backup application would be in general, and specifically on the data center, that you have some special requirements on the power quality you need and the response times that you need in these units because of the critical facility. So the target of these units would be naturally to be a fast start and high transient response application. Okay. So what we did here in Jenbacher, looking at what the market needs and the trends of the market of looking for greener solutions for their applications and monetizing their assets, is to develop a one-on-one diesel generator with gas benefits. Why one-on-one diesel generator? Because basically we can mimic the performance of a diesel generator in the key aspects. So here we are talking about starting, let's say, command since the pushing the button until full load of each unit of under 45 seconds. So this is something that has not been seen in the gas industry before. And the key of this, besides starting fast, we also can guarantee that the power that we are generating in terms of transient response is very high quality. So specifically tailor-made for data center applications. This kind of unit was what we call the fast start or the fast transient unit. So it comes in modules up to 3 megawatt. So it's, let's say, the power module that typically the data center industry requires for their applications. All of this, let's say, diesel-like performance, right, on the power quality and basically the output you need from this unit is also complemented with the benefits of the natural gas. So it's not just a one-on-one replacement, it's more than that. We're talking here about massive emissions reductions just from switching from a diesel unit to a gas unit. So here you can see some high-level figures. We are talking about 90% of NOx reduction and 25% CO2 reduction versus a standard tier 2 diesel. I'm gonna go on detail a little bit further later, but basically this is the untreated or without after treatment solution, so we can even go further on these values. And these values are, let's say, approved by their local regulations in North America, so couldn't be a problem to meet their specific site requirements. These units also have the possibility of operating with renewable fuels. So these units can nowadays take renewable fuels. I'm going to talk later about hydrogen, that is a hot topic nowadays in the market worldwide. So these units, for example, can take H2, or example, the gas engines itself can operate with biogas or renewable natural gas, etc. All kind of renewable fuels can be taken by our engines. So this is also some units that we know that nowadays can operate with these new fuels and also are also prepared for the future where we potentially see that all green or renewable fuel sources going to be applied. Another important thing about these units or the gas benefits itself versus the traditional, let's say, diesel application or other technologies, is these gas units, by definition, by rating by ISO, they have no operating hours limitation. So basically, although we're talking here about backup applications in terms of what you will use potentially the unit, these units can really operate continuously. So we're talking about 8,000 hours per year or so of continuous power. So there's no limit in that. And that's a massive advantage versus the standard, for example, diesel, that by warranty and by ISO definition, they use typically the standby rating, which is limited to 200 to 500 hours per year of operation only. Yeah. And another benefit we see globally in the application of natural gas in this market is that no on-site fuel storage is required. There were some studies by certification authorities where they basically prove that the natural gas grid is reliable enough not to depend on, let's say, local fuel storage, because, well, it's a reliable infrastructure, plus the gas network itself operates somehow as a storage system. Anyhow, is for any type of application you require also, or you want to have a local storage of fuel, obviously can be integrated easily with our solution. So basically, you can see with this new concept of solutions that here we're talking about a new business model, or something that is different for the backup power plant traditional in data centers. Before we were talking about just what we can say was an insurance policy, where you have your diesel backup power plant, where you basically will not operate just on cases of outages, and the main power source is the grid. So basically, this plant by concept is designed not to operate, right? With this kind of solution, or with the gas solution, here you can be, let's say, much more creative on the ways to monetize the asset, because as we were talking, this unit can have the backup, let's say, application. These units can be designed only for backup if you decide it, but also you can use this unit to, for example, sell power to the grid. For example, disconnect the data center from the grid in case the local regulator decides, because it was an over peak of demand, or even use the unit to what is capacity markets or peaking plants in case to sell the power for when the grid needs, or to manage the frequency on the area, or so on. So here is a much more, let's say, robust concept and much more creative solution than a traditional backup power plant, okay? And very, very important that this type of solution nowadays already can prepare for the green future. Let's go a little bit now on the performance, and to show and to see how we are talking about the diesel replacement on performance, right? So you can here you can see an example, let's say an exemplary curve of a G4 performance class on our natural gas engines, where you have a 15-second start since, let's say, command, the engine starts running, get up to speed, and in the 15 seconds you can apply the first load. This is an example where we apply for 25% step load, so in the 45 seconds you get the 100% load. We also can tailor-make this, let's say, this type of curve to match your project requirements. So even 100% load step is possible, and then obviously we have to see the let's say, the power quality you need on the voltage and frequency deviation, but basically, yeah, we can adapt all type of solutions. This example is taken from a real case on a USA application, where this engine is preheated, pre-lubricated. That's a standard, let's say, adaptation of our unit to operate in this way in the market. It's also, for example, a low voltage generator. You can see below in the disclaimer, but for us, it would be possible as well to do medium voltage solutions without any problem. We have that proven in the market as well. As I said, this is project-specific evaluation and performance. Just an important note here, because yes, many technologies claims about this fast start, but it's very important to know the difference between what is a fast start capability. So basically the capability of, let's say, starting fast a unit and apply load quickly. That's obviously a benefit. You can see these units can take it, but also that somehow sometimes is by the, let's say, is not as clear is the transient performance. So much more important that the fast start capability is also the capacity of accepting load for this unit, right? So you can see in this example, we have a G4 performance because basically on load application, the frequency and voltage drop of a G3 class is 15%. And here we are achieving values of a voltage drop of 10% and 5% on the frequency. So you can see this unit has much more, let's say, transient response capabilities as a, let's say, a standard ISO level. So this is a, let's say, top of the class performance of the unit, and even starting fast and giving the power in quality that the data center needs. Now, talking a little bit about the more traditional application, because although this is a mature technology and you've seen it for many, many years, the gas applications itself, over the years also there were some developments that were able to make this solution, let's say, more complete, more efficient, and let's say prepared for the future, right? So the traditional application we talked before about backup would be now a continuous application where the idea here is basically to operate the unit, let's say 24/7. So here, let's say the fast start or transient capabilities are not that important because basically you will operate the unit, let's say, on continuous or baseload applications, right? So the target here, it would be the efficiency of the unit. We're talking about then a higher standard starting time than before. Below 5 minutes can be, let's say, less than this. We have to see the application specifically, but basically has, let's say, a normal starting time for a application or, let's say, a technology like this. So indeed, the unit would be better for a continuous power supply 24/7 rather than a back application. And the interesting thing about this type of application is that besides the power that you can take, the electric power that you can take for the unit, that's basically the baseline that you will get with a gas engine, there's also the further option to, let's say, make the whole solution much more efficient. So for this, you can recover what is a CHP solution, so a combined heat and power solution, where basically you will recover the heat that the engine is dissipating. It can be from the from the water system of the engine and or from the exhaust gas. So there you have a lot of heat that in some cases is dissipating, is passed through the cooler and dissipated or released to the ambient as the exhaust gas. But here you can be, let's say, more creative, rich, completer solution than before. Or also there is an option that what is called trigeneration or combined cooling heat and power. So basically here you generate the power as baseline, you recover the heat, and plus with this heat you use a chiller in order to generate the cooling. So here you can have the continuous power for the data center. You have heat that you may require or not for your systems for installation, and you can have also cooling to use in the chillers, for example. So you have a much more complete solution, and here we're talking about efficiencies about 90%. So talking about green targets, not only the fuels that I mentioned before, H2, biogas, renewable natural gas, etc. Also on the green targets, it's important to have in mind the efficiency. Okay, so take as much of energy of that fuel input that you're having. And again, as by definition of gas engines, these units have no operation hours limitation. And again, due to the reliable natural gas distribution system, there's in principle, no on-site fuels required. Again, if the customer requires that is required to do this, obviously it can be integrated with our solution. And on these units, we're talking about on the whole portfolio we mentioned at the beginning. So from the 200 kilowatts up to 10 megawatt solution, we have all power models to cover. Going a little bit on detail or having, let's say, an example of what would be, let's say, a three-generation full, let's say, efficiency solution. This is a good example. You see here the engine on the left and the yellow line of the electricity. So basically, that is the power of the unit that will power the data center. Plus, you have here the heat exchanger to recover the heat. You can see on the system below there would be the hot water from the engine, and on the system above, what would be the exhaust gas recovery system, where, well, basically this heat can be either used by the customer or can be, let's say, dissipated with a cooler or to the ambient. So this is, let's say, a complete solution, let's say an independent solution, because if you don't need the heat, you don't have to use it. And plus here is integrated with an absorbent chiller in which you will take advantage of this heat to generate cooling, and then use it on the data center itself. So this could be a complete solution. And talking about, again, about the green applications, this can be integrated also with, for example, hydrogen and other renewable fuels. All of these type of solutions, although we're talking about the engine only, we can work and we can provide solution for this type of engines, all of which are about, on, let's say, a plug-and-play solution that is a container solution, basically. This type of complete solution is normally in the reciprocating engines market. So we can containerize on these standard solutions up to the 4.5 megawatt unit with the option of including the heat recovery or not. And this is basically would simplify the overall installation and capex of the project, and also the timing, because basically we'll deliver some plug-and-play solutions that only will require minimum, let's say, foundation works or BOP balance then on site. Just to give you a quick overview, this container package, for example, has the container housing, the radiator cooler, ventilation system adapted to any type of site temperatures. There's no noise emission, not only with the silencer, but the whole enclosure package is let's say, noise attenuated. So basically, we can get as slower as any type of site permitting requires here. We also include the control room. We can provide even MCC panels, circuit breakers on medium voltage, low voltage solutions. All obviously the piping and exhaust and gas drain and so on is integrated. And well, as said before, we have the option to integrate also on this type of solution, would be an after treatment package as well, and heat recovered solutions. So basically would be all type of solutions going to be plug and play. And also for the data center industry, we have developed also then optional to include the load bank in case, well, the customers want to, let's say, test these units periodically, as normally for the critical facilities is a requirement. So you can do it, and this, let's say, load bank is going to be integrated on the power, on let's say, on the container solution. So there's no need to put an independent load bank somewhere in the plant. Obviously, this solution, as we talked, that they are standardized, they have a standardized payload, but basically it can be tailor-made for any customer requirement. Good. Going a little bit on, let's say, the future of the data center and the future of the power generation. Now I introduce basically the two main type of applications of we see potentially in the data center industry, the backup and the continuous power. But let's talk about the future, the green solution, right? Hydrogen, you're all aware that is a hot topic in the market. Yeah, I've been to multiple of the events. The first question that comes is regarding hydrogen and how we see it and how is the future and, you know, what will happen with this. So basically, just to give you a quick overview, I mean, hydrogen for us is not a new thing. We have been operating with high percentage of hydrogen in our engines for the last 30 years or so on. This is summarized basically in 90 projects overall in 28 countries with high H2 content. So really the H2 application for Jenbacher that is specifically specialized in particular gases or complex gases is on new in the market. What is new in the market and what we see more trends to do in the future is to, let's say, scale these applications to use over time as much of hydrogen as possible. And let's say, well, even mix with natural gas. So we see the trend of going to, let's say, fuel renewable solutions instead of, you know, mixed solutions with, you know, complex gases or natural gas. So indefinitely we will see more the green hydrogen application in the future, right? And please remember that you have the Q&A sections to submit the questions that we will answer at the end of the presentation. Good. Going a little bit deeper on the technology, the path forward on hydrogen and renewable fuels. So basically, you have here a very simple but concrete graph on the different type of technologies that from now to the future. So basically, on the left you have the standard diesel application that we all know that is the the standard, let's say the most traditional solution or for backup power plant before new technologies emerge, and before let's say all the green targets in the market and global trends. What we see nowadays that these basically backup solutions that are not variating and are highly pollutant. We need to do something about it, especially in the green projects and in greenfield projects and a new project starting to level. So some other creative solutions are required for the future, right? So the hydrogen we see as it is nowadays let's say a current solution that we can adapt and we can deliver. But the constraints nowadays, as you may know, is sometimes, let's say, the accessibility of green hydrogen itself, and let's say the cost of accessing this hydrogen is high nowadays because of the new market. But eventually this trend, let's say, with scalability, this price or this lack of competitivity to reach the fuel is going to come down in the market. And with this type of solution, basically will be no CO2 emissions in our gas engines and nearly no NOx emissions. So we're talking about a super clean solution. When you have enough hydrogen to operate this power plant, okay? What we see as a bridging technology and a realistic solution for nowadays for this type of market is the traditional gas application that I was talking about before, in sense of with this type of solution, you can reduce the CO2 emissions and the NOx emissions on massive terms, even just from a standard unit with no after treatment. So the natural gas unit nowadays has much more benefits and much more, let's say, green targets or green idea than the diesel itself. And with this units, also please remember that you have the higher efficiency. So it's a complete solution. So here, when we are talking about green targets, don't forget the efficiency and the possibility also to monetize the assets as the overall economics, right? And just another disclaimer on the gas engine technology, although, it's a mature technology, right? And yeah, nowadays all type of alternative new technologies are appearing on the clean, let's say, power market. For example, fuel cells could be an often. But just please remember also on the green targets and solutions, the life cycle of these kind of units. Although let's say the gas engine is a traditional technology, it has these years of development and polishing and making more efficient and more durable. So basically, this was the past of the last 50 years or so, where the units gain efficiency and gain life cycle time because of the market requires so. And nowadays, this is a benefit versus the new technology. For example, these units can operate up to 80,000 hours before the first overhaul. So basically, you're talking here about 10 years of continuous operation. So you can imagine continuous operation, 10 years, that's 80,000 hours. That's a lot that you can use. And then after that unit reaches overhaul point, it can be overhauled, and basically they can extend their life again for 80,000 years, and potentially there's the chance of doing one more time. So we are talking here about pretty 20, 30 years of continuous power. So this is a lot, and compared to new technologies that maybe operate, I don't know, 20,000 hours, that are new technologies that don't even have clarity on how much they can operate before, being exchanged. So please have that in mind when you're analyzing your project, the overall, let's say, life cycle of the unit. So basically, the three type of application that nowadays we can achieve with a gas engine, with a gas generator. As I was saying before, the standard, switching from diesel to natural gas. Here you have a massive reduction on the emissions just from the starting point and with the full available technology. The other option could be, let's say, reaching a dual fuel solution where you have the hydrogen and the natural gas input to operate, depending on the cost of the fuel, on the availability of the fuel, etc., that you may have. Or I'm going to go in detail a little bit afterwards, the possibility also to mix the natural gas with the the hydrogen, sorry, with the natural gas. So there we can achieve mixtures of 70%, 60% H2 content on our engine. So here is a clear example with the current technology that if you have the hydrogen, we can operate and perform within this hydrogen. Or the third option would be, and maybe the targets of the future will be achieving 100% H2 application. Nowadays, we have a solution not only work but also deliver and proven in the market. Then we're gonna talk about it in our business cases section, where you have here no CO2 emissions and almost no NOx emissions. So this is a super clean solution. The NOx, let's say, remaining emissions is due to the nitrogen present on the air and the high temperature combustion. So there's also some. It's going to be some remaining of NOx generating on the internal combustion, but that's proper of the high temperature combustion is. But there is also the potential option also to include the after treatment solutions and reduce that to virtually, let's say, non-existing emission values. Here a little bit of the landscape, or let's say an image of what can be a data center power solution in the future, where you can see on the left wind electricity and solar electricity generation. That nowadays is extended worldwide on the type of, let's say, renewable energy production. But also remember, this kind of energy is intermittent, so the wind doesn't blow always and the sun doesn't shine always. So basically, you have there some, let's say, power storage constraints. If you're talking, even in that power solutions could be interesting, let's say, potentially in a continuous application, but again, this could be an intermittent power production. So you need somehow some type of power that will be always present, let's say, would be stored, and also, and very important, that can deliver power in the power quality that the customers need. Okay, so that's how you complement this type of solution with a complete, let's say, green solution here. You can use this power to have an electrolysis and generate H2. The H2 can be injected in the engine, so you can burn it live to have, let's say, power at high quality, or you can store it, for example, to complement peaks, or if it is a backup unit to operate it when it's just backup, and then you generate the power you need. And this is what is called basically a microgrid solution, because also you are connected with the power grid and also the possibility to integrate with renewable fuels. We actually in our portfolio will also have the chance of supplying a microgrid controller that can control this overall plant. So basically we have our single point of control system to interact directly with the customer point. Okay, and some other type of other traditional gaseous sources, as the biogas that you can see there in the left, that we can burn biogas as itself, but there's also the chance to reach biomethane or renewable natural gas. So it's basically cleaning up or mixing this methane to, let's say, reach natural gas quality, which this fuel again can be burned directly on the engines or can be injected in the natural gas grid in order to achieve, let's say, compensate the CO2 in the overall, let's say, carbon footprint of the plant. And also with the H2, there's possibility of when you're generating it to sell it or to apply it for transport and other applications. In parallel of this power application, right? And to finish my part, here is a print of what we can do in H2 terms, in hydrogen terms, with our engines. And this is live. This is nowadays. This is what we can deliver to the market now. So basically, every engine that we sell nowadays comes with this icon, the ready for H2. That basically means that this is a commitment from us that this unit. I'm going to talk about the percentage, but basically this unit can tolerate a certain percentage of H2, and the commitment that this unit can be converted in the site to fuel H2 application, again, when I mean, we can adapt to that. It's no problem. But when the market, let's say, leads to a point where the green fuel is available and on the competitive price to make the overall project. So every engine that we sell nowadays comes with the commitment. And also, there's the possibility to, in case you have installed fleet of Jenbacher, there's also a very high chance that your unit is applicable to do this, let's say, to apply for this conversion package to operate 100% with H2. We have to see, obviously, analyze the project a little bit in detail, but yeah, basically, it's a high chance that any Jenbacher unit out there is possible to make this additional field. So basically, to go quickly on the possibility we have nowadays. So basically, we have any unit we sell as standard for any type of fuel. Basically, is capable of accepting up to 5% hydrogen with the natural gas without any modification whatsoever. So with the engine that you get nowadays, there's also with some small modifications. We're talking about the gas train and some minor parts and adjusting control and so on to run this unit. All of our units in the portfolio up to 25% H2 content mixed in natural gas. That we see nowadays with this solution we can deliver nowadays is and the volume of and the availability of hydrogen in the market this percentage is more than high for multiple applications. Then we have the option B of let's say delivering what we call special engines categories, in which we can reach high percentage of H2 mixed with the natural gas, mostly 60% mixed with the natural gas. And we even have one line developed that can operate up to 100% hydrogen. Hydrogen I'm talking about, can operate up to 100% hydrogen. So this unit can operate with pure hydrogen injected on the engine. Also, there's a possibility to have let's say a dual fuel unit where we put it with 100% natural gas or 100% hydrogen. And obviously, for all our products, we have our target to achieve the 100% hydrogen solution. There you can see on the right hand side all the details. But basically, on around 2025, we expect to have our full portfolio to operate with 100% hydrogen. Thank you, and I'll revert back to you, Curtis.
Thank you, Santiago. We want to take a few more moments of your time to share some real-life cases that we've have our successes in packages that we've moved forward. But I also wanted to remind you that if there's additional detail that you would like or questions, please type them into the question and answer portion. One of our projects is a hyperscale data center in the U.S. using 20 of the fast start 3 megawatt units that we touched on, or Santiago touched on earlier. This is a factory package containers to expedite installation and delivery. High temp, high elevation installation without any D-rate in this particular application. No on-site storage is needed for fuel, as discussed earlier. And the study has been completed, and it's a proven field validated technology. The fast start power quality is one of the keys that was mentioned earlier. Also, is the power quality is not it's not necessarily just fast start. We need a good transient response, and that met the customer's requirements. Achieved through port injection to mimic a diesel application. This is as I mentioned, a 60 megawatt hyperscale data center here in the US. Another application that we're working on finalizing is a H2 application that to move down the scale from a previous slide to a cleaner application. This is a small application of 6 megawatts worth of 1 megawatt generators, our JGC 420. Now, its goal there is to be carbon neutral. They import their own H2, which has it's a dual fuel application, meaning that should they run out of H2, it can switch over to natural gas and continue to operate. it happens to be not in the U.S., but obviously we can see this kind of thing happening here also as we become more and more conscious of the need to be cleaner in the world. This will replace some diesel generators going forward, and the project's in process right now, and we expect it to be up and running by October, November this year. Another application that we've been involved with is a tri-gen application in China. Instead of using the traditional diesel generators, our power generation system is the primary energy for this project. It reduces CO2 and NOx with high efficiency. Backup power is provided by the grid instead of the other way around. This is 5 of our 620 units. The 620 is the platform for the Fast Start package. And that's it for us today. We appreciate everyone taking their time, and we can move to the question and answer section. And at this point, and please enter them as needed.
Thank you very much, Curtis and Santiago. Just a reminder for the audience, in order to ask questions, you can send them in via the questions widget. Just type them into the box at the top right-hand corner of your screen and click submit. Now we'll start our Q&A session. Let's start with this question. What are the NOx emission levels of the diesel replacement gas engine? Do they comply with the US EPA requirements?
Okay, thank you. I'm going to take this one, Curtis. Basically, the lower NOx emissions of our engine without after treatment is 0.5 grams per HP hour. That basically converted in other units would be the 250 milligrams per cubic meter, 5% O2. So basically, these values, yes, they do comply with the EPA regulations. In case any lower values of emissions are required, it can be achieved via after treatment solution, depending on the target that you need. It can be SCR or oxycat to, let's say, get down different parts of exhaust gases. And basically, this can be integrated as part of our solution, either in container or let's say, shipless units. This is applied not only to NOx, as the question pointed out, but also on other, let's say, gas emissions, such as CO or CO2, and so on. And basically, well, important also to know, we talk about the replacement and the requirements of the EPA. Typically, the natural gas plants or the gas plants itself can be designed and let's say for local regulations, do not have hours limitations because of the emissions. In contrast of the diesel power plants that you know that in some states you are not getting the permissions to be the new power plants because of the emissions and so on. So with this with natural gas, you typically do not have this kind of limitations. So these units can, well, as I talked before, can be either designed for backup or continuous, but at the end they are continuous units, so that they have no limitation to operate it. Versus what is the units of diesel that typically are designed for standby, not only by warranty, but also for site permittings. I hope that answered your questions.
Great, thank you, Santiago. And are the hydrogen solutions a proven solution, or are they still in pilot phase?
I can take that one. So these are proven and reliable solutions. We've, as mentioned earlier, Jenbacher has been burning gases with high hydrogen content for 30 years. Recent years, we've developed projects with 100% hydrogen fuel input, and the goal is to get to 100% hydrogen availability for all of our units. I showed a quick overview of a data center in the Netherlands, which we're supplying units that are 100% hydrogen capable and can be flexible in the quantity of hydrogen that they use, so they can blend the fuel as needed or use it 100% gas, 100% hydrogen, whatever the case may be. We try to be as flexible as possible to allow for customer flexibility as it is.
Okay, great. And speaking of hydrogen, can the fast start unit accept renewable fuels like biomethane or hydrogen?
Yeah, I will take this one. Yeah, basically, well, we talked about hydrogen before in the section, but the question also pointed out of biomethane. Yeah, basically biomethane is for us it has the same properties as natural gas, so there's different, yeah, whatsoever with the natural gas standard application. And the hydrogen, yeah, we talked about before in detail. Basically, the units nowadays can be mixed up with natural gas, again with 25%, with pretty much no modification on the engine, 60% with a modification, and can even run depending on the application you have on the power module up to 100% application. So yeah, this unit yeah can be adjusted. On the fast start unit that the question points out a little bit. On the 3 megawatt unit, yeah, this unit can operate with the mixtures that I'm talking about. Not yet developed for 100% application, but it's been on R&D and R&D phase. So it's gonna be there in the market when basically you need it. And basically also an important point here about the fast start itself that they are asking is that basically this unit has, in order to achieve the fast transient and fast start category, this unit basically has some extra technology versus standard natural gas. And this extra technology that we have developed for this is also applied on the hydrogen engine. So basically, let's say the baseline adaptation in order to operate with 100% H2 in the future are there already on the fast start unit. So basically in this type of unit, any minor upgrade that will be needed on the future is going to be, let's say, minimum because the technology is there already.
Fantastic. Thank you, Santiago. And another question that we have is, what is the transient performance of the diesel replacement unit? Does it comply with ISO classes?
Yes, basically this also I talked a little bit about before. So basically the transient performance that we can guarantee in our unit is G4. That is basically, let's say, a customer arrangement performance. So exceeding the standard ISO classes G1, G2, and G3. So our faster unit was specifically developed for that, to provide high quality power to the customers and to their needs. In this case, obviously, we can adapt the frequency and voltage deviation on your specific, let's say, requirements. So I invite you, in case you have let's say, a project that you're evaluating and so on, to reach us, and we can develop on a tailor-made solution to achieve the performance parameters you require for your data center.
Perfect. And do the container solutions allow the possibility of adding heat recovery systems as part of the package?
I can take that. We do. Yeah, all container solutions have the possibility of incorporating heat recovery, engine water and exhaust, whatever the demand is. These are our standard procedure for us at Jenbacher. 2 and 3 container style packages will accommodate whatever is necessary, including additional emissions control equipment that can be mounted on top per the requirements wherever you happen to be.
Thank you, Curtis. And another question from the audience is, does the company have data on how much CO2 is generated during operation? They're looking at CHP as a source of heat, electric, and CO2 enrichment for year-round indoor growing of produce. They also have permission from their electric grid to buy any extra power produced. This also fits with the current state administration's green and CO2 neutral proposal.
So we do have that data. We just would have to narrow it down to which product. I mean, in general, I can't just say, yes, we produce this much CO2. It's the application specific. And we can share that with you should you have a project in mind, a physical size in mind as far as how much power you needed. We would just need to kind of, if it'd be okay, we'd like to potentially reach out to you, or you can reach out to us, and we can do a deeper dive into that to help answer that in a more complete fashion.
Just Curtis, to complement, basically, yes, and this type of application is what we call a greenhouse application. So it's very popular, and we have, a massive amount of engines installed for this kind of application. Specifically in Netherlands, there's a very, very, very common use for indoor growing. So yeah, definitely we can help you up there and find a solution because we do it nowadays.
Great. Another question is, can the same unit dynamically switch between H2 and NG? It looks like the unit did rates on H2. Is that correct?
Yeah, let me take this one.
Sure.
Yes, the unit can operate, can switch during operation from natural gas to H2. Actually, in the project we presented before, there is this option in which, let's say, the blending and transition from one fuel and the other is going to be during operation. So yes, it can be done. And regarding the rate question, let's see, each engine for each fuel has, let's say, a guarantee rating. In case of, let's say, the same unit on natural gas, operating 100% natural gas, and the same unit operating in 100% hydrogen, yes, it has a different rating. But basically, a unit that is going to be dual fuel as this one, as we are talking before, with switching during operation, we provide a full solution to reach, let's say, a certain power level. In this case, our maximum level with this type of solution that we can achieve nowadays is 1 megawatt. So basically, when we deliver a unit, it's not that the engine is going to have the rate when switching the fuels. The full power commitment is going to be guaranteed for any type of mix of the fuel.
Perfect. And as we are close to the hour, I'll ask this question as the last one. On the type 4 with H2, is the unit rated from NG rating? What is the efficiency and actual NOx level? NOx level.
Yeah, let me take this one because it's joined with the one before. So basically, yes, I was saying for each, let's say, fuel type is a rating guaranteed. In case of, let's say, let's say, talking about the type 4, let's say, our big units, the 420, that can reach up to 1.5 megawatts in natural gas, roughly, and 1 megawatt in H2. But again, when we deliver a solution, we, let's say, compromise to one rating itself. This has to do, with the fuel itself and combustion and so on. That basically the unit has to be, let's say, this item has less rating than the natural use unit. That's implicit with the fuel itself. So there's going to be limitation there. And regarding efficiency, we're talking about the same efficiency levels, or pretty much the same efficiency levels as a natural gas unit. So you're talking about efficiencies above 40% for this unit, for 43 or so. So basically, yes, although it has, let's say, the less power, the same iron, the efficiency overall is the same. Thank you.
Great answers, Curtis and Santiago. We'll have to close our Q&A session, but don't worry if your questions haven't been answered, as our speakers will get back to you. So that just leaves me to thank Curtis and Santiago for what was a fantastic presentation, and to INNIO Jenbacher North America for sponsoring this session. To the attendees, you can download Jenbacher's latest Data Center Power Solutions datasheet and press release about INNIO Jenbacher's engine to power 60 megawatts hyperscale data center power plant in Ireland using the resource list widget. You will also receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website www.pmi-live.com. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at BR Webinars for daily updates, and join our LinkedIn group, Business Review Webinars. Thank you once again, and I hope you all have a nice day.